All right. Morning. Second day of Blink. Everybody excited? Sounds like it. I'm getting to that part. All right. So, hi, I'm Sami. This is Alex.
Hi, I'm Alex.
This time we're from the Headless Chrome team here to tell you a bit about Headless Chrome. So, thought I'd start with definition. What do we mean when we say like headless mode? And essentially, it's a browser without a UI, Chrome without Chrome. And the difference is that instead of a person using the browser, you'll have like some kind of automated program, like a test harness or some kind of data extraction program controlling the browser, and it's like intended to run in a server environment, not a normal desktop PC. And just to be clear, what we're not doing here, we're not trying to build another WebView UI component. Like it's not meant to be like an embeddable browser widget that you use in your application. So that's a different problem. So headless browsers, there's actually several solutions to this kind of problem already. Folks are using regular browsers in like a virtual frame buffer environment, running like a full browser UI. And then there's more focused solutions like Phantom.js or NW.js that sort of actually implement a headless browser. And then there's also these more like UI toolkits like Chromium Embedded Framework and Qt Web Engine that can also be used in headless mode. And then on the client side, there's lots of programs using these headless browsers like Selenium and their WebDriver backend for automated testing, and also the Karma test runner for JavaScript. And in Chromium, we have also things like telemetry, you probably know about that, and the layout test runner is running a headless browser. But these solutions have some problems associated with them, like the virtual desktop ones, they tend to use a lot of resources, and it's kind of difficult to set them up because there's lots of dependencies you have to work out. Some of these might not support the latest and greatest web platform features like ES6 service workers, so on. You might not get automatic updates, and some of these might encourage you to build your, for example, tests in a way that result in flakiness, like you might end up polling for UI updates, and that stuff isn't really reliable. And finally, many of these solutions don't really consider that you might want to run untrusted content, like they don't provide any security isolation. So these are some of the reasons why we kicked off this Headless Chrome project, see if we can improve some of these things. And we've been sort of working on this, experimenting for a while now, not really telling anyone about it until a few weeks ago someone found out, made a tweet. Someone said that this was the most retweets ever for like an unreleased web platform feature. So yeah, I guess it's nice to see some validation that people think that we could be having something better here in this space. They also found our bug, so feel free to go and start that if you want to follow along. All right, but let's talk about Headless Chrome itself. So while making these slides, I was sort of trying to figure out how to best show what it's about. So maybe I'll just show a picture. There's nothing. Get it? Okay, so seriously though, it's not that different from regular browser. Like there's a browser instance, there's a bunch of renderers that are hosting tabs, and the real main difference is that instead of the user at the top, you have the embedding app. But this is sort of the place where it gets a little interesting for us because we're actually experimenting with two different variants here. On the left, you have the sort of traditional model where your embedding app is controlling the browser using this remote DevTools protocol over like a WebSocket connection. So it's like two different processes. This is how things like telemetry and Selenium work today. Then on the right, we have this sort of alternate model where your app is actually a C++ app that's embedding a headless library that implements the browser. It's like same process. And there's this new DevTools C++ API here that you use to control the browser. And the reason for this split is that with the C++ model, you get a little bit more control over how things are set up. Like you can customize networking. Maybe you want to load pages from disk instead of the internet, for example. And you can bring some new functionality in the form of these modules. Alex will talk about that more. But just to be clear, we kind of expect most people to go in this traditional model. Like it should give you most of the things you need. This is sort of like the power user case. All right, so how's it different from regular Chrome? Well, if you think about the layer cake that is Chrome, you could just imagine us taking off the Chrome layer and giving you everything below that. So that means there's no Chrome level features like profiles, sync, safe browsing, things like that. There's no UI, it's all off-screen software rendering. No extensions for now, and some other stuff like audio is not supported. But what do you get is, well, everything below the content layer. Like you have all the latest platform features from Blink, all the nice profiling tools. Chrome gives you lots of nice stuff. So this is sort of a high-level view. So I'll turn it over to Alex to talk more about specific things we're adding on top.
Hi, so the main thing about a headless browser is it's going to be controlled by DevTools, no matter which we use, whether it's the regular over WebSockets or whether it's using the C++ API. And we're going to teach DevTools some new things. So we're going to teach it some also about web data extraction. By that we mean things like taking screenshots and capturing the DOM. DevTools already has a bunch of functionality there, but we're going to extend that. Pavel recently added a new domain to DevTools. It's the browser domain. This is pretty cool. One of the things you can do in this is you can have one DevTools client can actually forward commands to another tab. That's pretty cool. We're going to teach the browser domain how to be able to open and close tabs and actually create new sessions. Let's talk a little bit more about sessions. So one of the things you want to do with headless is make the browser deterministic, because a lot of times in testing you can get bitten by it not being deterministic, and there's lots of sources of that. One of those is if you have a tab open and two tabs open from the same origin, cookies are shared across them. This is normally what you want to happen, but when you're testing stuff, that probably isn't what you want to happen. So we're going to have the ability to create sessions and isolate them. Another thing we're going to go and do is add this concept of virtual time. So normally, when you go and have timers, you actually have to wait wall time for delayed task fires. We're going to change that. To be able to stop and start timers and fast forward them. I'm going to do that in more detail in a moment. Another thing we're going to do is we're going to go and make time and date deterministic. You'll be able to set them, and you'll be able to see the random number generator. And other things we're doing is, well, obviously we have a C++ library, so we need some bindings to DevTools. I mean, you could talk raw JSON to it, but that's a pain. And likewise, we're going to provide JavaScript bindings. DevTools internally actually has some JavaScript bindings. We're just going to go and customize those slightly and make those available externally. Other things we're going to do on the C++ level, you'll be able to go and override the protocol handlers, and we're going to introduce Mojo modules, which I'll go into more detail in a moment. So let's talk about web data extraction. So one of the things you probably want to do with headless browser is take a screenshot. And at the moment, you normally have like a view of the screen. Sometimes that's what you want. Other times you want to take a picture of the entire web content. You're going to be able to do that, and you're going to be able to go and make thumbnails and things like that. Now, DevTools already has abilities to go and dump the DOM. One of the things it isn't, though, you can't actually dump the entire page atomically at the moment. We're going to go and extend it so you can do that. And also across iframes as well. Modulo out of process iframe, which we can't make that atomic. And other things that we can get via headless is obviously things like traces. Those are already there. We can do that. And DevTools always has lots of interesting information about resource fetches and timings. Quite a rich amount of data you'll be able to get a hold of there. One of the things it can't do at the moment, but we're going to add, is the ability to go and get some data about the layout and paint trees. That stuff's not been designed yet, so stay tuned. Let's talk a little bit more detail about session isolation. So one of the things that people running sort of WebDriver and Selenium type tests tend to do is they want to go and get the browser in a known state. For example, they want to make sure that only the cookies they want loaded are loaded, and things that shouldn't be cached aren't cached. So typically they would go and delete some directories on the file system and then spawn up a new browser. And to make the isolation, it actually had n full browsers, each of them its own renderer. This is not the most efficient thing to do from a resource point of view. So we're going to add the idea of having sessions. Now, a session is a little bit like having a incognito tab, in that you're going to get unique cache, cookies, local storage. Initially, it'll be empty. We're hoping to add the ability to serialize these and maybe duplicate them. So you can imagine that your test might go and do whatever sign-up flow you might do, get the cookies in the known state, and then duplicate that and run n tests in parallel, hopefully save you a whole bunch of resources. Another thing we're going to go and do is add virtual time. So virtual time is two things. It's partly for determinism. For example, the network stack comes in completely not in random order, and actually while you're waiting for network tasks, JavaScript can be spinning timers, doing all sorts of stuff, and that may not necessarily do what you want. It certainly makes things non-deterministic. So we're going to have the ability to stop timers firing while you're waiting for network requests. And this will also include when we're producing frames in this time either. And then another thing you can do with it is if you do have all the resources there, we can have all of the timers which are due to fire in the right order back to back without actually waiting for the wall time. So I've got a slide to explain this a bit better. Now at the top row you can see up here two timers, timer firing t equals 1, t equals 3. Normally you'd actually have to wait all that time. However, we can fast forward them so they go immediately back to back, no actual waiting, or we can completely suspend them and then later resume them. So how is this all going to be controlled? Well, I'm sure you're all familiar with the rather wonderful DevTools. Behind it, there's this protocol, it's JSON, and it has lots of interesting features. There's lots of commands in it. There's things that can go and, for example, execute a script on a tab. You can go and insert and modify the DOM. You can receive events, for example. You can find out when something's wanting to navigate or get events when DOM gets inserted. And there's a huge plethora of commands there, and we're going to make all of these available to users of Headless. It's really, really a very rich set of stuff, and it's pretty cool what's already there. I'll give you an example of how this works. Some of you probably are aware of this, maybe some of you aren't. So on the left, you have a DevTools client. This could be like a Node.js app. It could be the Phantom.js style thing. It could be another tab, and controlling another renderer on the other side, on the right. So let's say we want to go and eval some script. For example, here's 1+1. We send a bit of JSON over, and that gets evaluated on the target page, and then we get back a result, in this case, number 2, and no exception was thrown. As you can see, the request is quite simple, but the result's actually fairly complicated bit of JSON. Here's another example, load event fired, and we got something back. Actually, some of these events can get really quite complicated with the JSON. So you don't really want to go and parse this yourself, so we're going to provide bindings. We've already got landed C++ bindings. You can try that today. There are JavaScript bindings internally. We're going to go and expose those, like I said. The bindings give you a number of things. They're type safe. They're much easier to use. It's worth mentioning they are actually key to a specific version of the protocol. Now, the protocol is actually split into stable and experimental APIs. The things that are stable generally really aren't going to change. And the experimental stuff, well, some of it's more stable than others. Really, you probably shouldn't rely on anything there not changing. There's a few things in there that probably should be stable, and I think Pavel's intending to go and stabilize those, which should be great. Let's talk about what these bindings might look like. So in C++, this is actually cut out of our headless shell. You can basically go and do something like this. You know, get your client, get the runtime domain, and evaluate some scripts, and here's your callback. And in JavaScript, it's rather more compact, and actually in ES6 style, it's even nicer. So you can do a sync await, so it's pretty sweet. Here's how a event looks. You have to go and tell the domain, for example, here's the page domain that you want to know about it. You add an observer in C++ or a listener in JavaScript, and you get a simple callback. These can come in at any time. Let's talk a little about network customization. Now, this is like a real power user feature. I actually don't think this will be widely used, but it's there and it's going to be pretty powerful. So a C++ embedder is able to go and implement the protocol handlers, so HTTP, HTTPS, or anything custom, even file. Things that might be used for this. So I can imagine people might want to go and fetch pages from disk instead of actually touching the internet. You might want to go and replace specific resources, or maybe you want to have runtime generated resources. That's a fairly common thing to want to do in testing. And this probably makes it a bit easier. I mean, you could already do this before, but you may not now need to have a web server spun up again with all your testing. So that might be nice for some people. Another thing that we're going to go and do is introduce Mojo modules. I'm sure a number of you are familiar about these. The way we're using these is to go and expose JavaScript bindings in a tab for C++ objects. The things you might want to do with this, well, let's say you have a test run and you need to get an asynchronous result from JavaScript. There's other ways you could do that, but this lets you have a command you can run in C++, for example, dump your text or result. Other things you might want to do is to go enable airplane mode or other host OS abilities that aren't exposed on the web platform. Now here's an example of how this might work. On the left is Mojo Service implemented in C++. On the right is your renderer. Actually, you could have a C++ bit of code here, but we're assuming it's going to be JavaScript. So here's an example of a very, very trivial Mojo service, something just to send test results back. So you can request this to be injected into the tab in JavaScript, and here's a convenience wrapper we've used to go and provide the interface, the Mojo interface. There's actually a more complicated thing which is for normal Mojo modules to go define their bindings. That's still there, but this is quite nice and easy to use. And here's how this will look like in C++. So, for example, let's say you pass all test results, all passed. Well, there you go in C++. You've got it back again, and you can have your test to see that you got the right results. Okay, so tell me about distribution.
Right. So Alex talked about some cool things that are coming. How do we get those into the hands of our users? So there we have two different stories because of these two different flavors that we're looking at. So for the use case of running like a standalone browser in headless mode, our vision is that one day you'll be able to pass this -- headless flag to basically any version of Chrome, and also enable remote debugging so you can actually control it. This isn't quite there yet, but what we do have is something called headless shell. You can think of it as a content shell without the UI part, so you can actually run that already in like a non-desktop environment. Then on the C++ library side, this code lives in headless, like there's a headless directory in Chrome. It'll be distributed as source code, so we're not intending to package any binaries. Like there's not going to be a stable ABI. We're going to strive to keep the API stable, but the ABI will change. And there's a link to some instructions on how to get started. So what's next? Well, first of all, we should finish all the things we sort of promised in the past 20 minutes. We're going to look at making sure all these popular test harnesses like WebDriver, Selenium, those things integrate nicely with what we're shipping. Right now, our headless shell and the C++ library, they only support Linux, so we want to definitely add Windows and macOS. Node.js package is something people tend to ask for quite a bit. So the idea is that you can sort of import headless browser. It'll manage all the processes and web sockets behind the scenes and give you like a nice API to talk to the browser. Definitely want to do that. Then some of the things like the session isolation bit that Alex talked about. The way it works is we have to actually spawn a different renderer process for every session. So there's some memory overhead in doing that. So we sort of want to limit or reduce that as much as we can. So you don't have to worry about creating these sessions so much. Then on the feature side, like WebGL has come up many times. We're either going to do software rendering or make it possible to talk to a GPU without needing to have like a desktop installation. Chrome extensions, maybe we're sort of still looking into that. People are curious about getting that as well, so we'll see. And then finally, like we definitely want to use some of these capabilities, like getting traces from a bunch of web pages to guide some performance work and see like where the bottlenecks are on a bigger scale. So that was basically our whirlwind tour to headless. Here's a 15-second tutorial on how to run the headless shell application. Give it a try. We have a mailing list. We have documentation, believe it or not. if you're interested in using this stuff, please come and talk to us and tell us what you want to do with it, and we'll make sure that, or we'll try to make it possible. But yeah, that's about it. Thanks. I think we have a bunch of time for questions, so.
Hi. Any kind of collaboration with the PhantomJS project? Any kind of PhantomJS compatibility so that PhantomJS scripts could just run?
Yeah, we're talking to PhantomJS a lot about like making sure we can support the same kind of features. When it comes to script compatibility, like most things are possible, but there's some limitations because PhantomJS, everything runs in the same process, same thread essentially, but we have this renderer split from Chrome, so some things will need to become asynchronous that currently are not in Phantom, so some bit of porting is needed. But we'll keep talking to them to find a way to make it as painless as possible.
Hi, Sammy, Alex. What are the chief challenges, or some of them at least, that you faced in the process of kind of bending Chromium to work in this way?
Well, the main thing you have to do is swap out all the parts that talk to the graphics, basically. And I admit we sort of got lucky there because someone already did the hard lifting in that area for us. There's this thing called Ozone that lets you basically make Chrome talk to a different kind of graphics backend. So what we've added is a headless backend that doesn't talk to anything. So that was sort of the one big change that needed to be made. We might need to do some more work there because I mentioned the headless switch for real Chrome. Currently, Ozone is a build time configuration thing, and you can't really make that become a command line flag. So I think we need some more work in that area.
You got a kind of a hacky patch that does it, though, don't you?
Let's call it a proof of concept.
Okay.
Yeah. So if I measure performance on a headless Chrome and if I measure performance on a regular browser, will there be any difference?
I can promise you that there will be a difference. That's actually one thing we need to look at. Like, how can you translate performance data from headless into the real world? Like, obviously, you don't have a GPU, so some things can be different. I think, like, when it comes to measuring like resource usage and CPU time, I think you can make a mapping between those two. So we'll look into it.
I just have one more question.
Uh-huh.
So if you do CPU throttling or network throttling in the headless browser,
Mm-hmm.
will it be affected by, like, how can I make sure that it's not affected by other external load on the server? Or are they?
I guess that kind of depends on your server setup. Like if you use things like C groups or containers, maybe I think you can do some performance isolation between those.
Thank you.
The virtual timer stuff is really interesting for eliminating flakiness, but what about ways of basically discovering race conditions by fine-tuning timing events? So in other words, have you thought about ways to sort of replay a browser sequence with timers firing in different orders to try and sort of fuzz test for race conditions?
That's actually an idea we've had before on the scheduler stuff. One of the things is quite apparent when you do layout test debugging, and when we were doing some of the scheduler stuff, is there was all sorts of implicit order independencies. And we did talk about having a fuzzer because you probably could go and perturb the order in which the various tasks run, and I don't think we ever pursued that, unfortunately. It seems like a good idea, though.
Yeah, we should reconsider. Like doing that manually has been really effective for us, like adding delays to various places.
You mentioned layout tests. Can we, like, this determinism stuff seems a killer feature for reducing our flakiness.
Yeah. Yeah, layout tests, moving layout tests to something like this would be really nice. I don't know if I want to
I-
stand up on stage and say that I will be doing it.
I understand it's quite a lot of work to do that.
Yeah, but yeah.
There would be a lot of benefit from the feature where you said you can advance the browser to a certain state and then shard it.
Yeah.
To do that on layout tests would be enormously beneficial.
So we're going to add that ability to DevTools. So hopefully you might be able to do that somehow by default. Although it had to be a headless version of the browser rather than...
So you mentioned the C++ library, and you say you don't want a stable ABI, but you do want a stable API. When I was looking at the code samples you have there, you're exposing both Base and Mojo, both of which we evolve in Chromium with just global rewrites across our code base, and Mojo in particular has been evolving really quickly. Are we going to lock down the Base and Mojo APIs in order to support this, or are developers going to be left sort of having to keep up with all our
Yeah, there should
internal
have been
API changes?
should have been an asterisk next to that. So we're gonna try and like, especially the headless API, we're trying to keep that stable. But as you said, like out of necessity, we're exposing some details from Base, Net, and Mojo most recently. So I think we'll need to make sure the messaging is right, that these things might change. Like one thing we don't want to do is invent a new wrapping layer for all of this, because that's not really a sustainable model. So we don't have a perfect story, I think. All right, well, thanks again.
Thank you.